Hello, everyone. Thank you for coming to my topic. In this session, I will share some experience of discovering Flash zero-day exploits in the wild, and I also will introduce a little tool how to identify Flash zero-day exploit. This is my agenda. First, who am I? I am researcher of Trend Micro zero-day discovery team, and I'm also a NT-APT engine developer. I'm interested in discovering vulnerabilities and writing exploits. Currently, I focus on Flash, Android system, and OS X kernel. In this year, I have discovered several Flash zero-day exploits in the wild, and also have reported dozens of Android system bugs to Google. And I'm also doing some research on OS X kernel now. Let me introduce the background of this topic. We know that Oracle introduced click-to-play to Java applet, and the browser vendors introduced several UAF mitigations. So Flash player exploits boomed in 2015. So I can call 2015 is Flash year. We can see that zero-day attack targets are mostly Flash player in 2015. It begins with CVE 2015-0310 and doesn't end yet. So in this situation, after Microsoft introduced isolated heap and memory protector in late 2014, I guessed that Flash player will be the most popular target in 2015. So I decided to do something to catch Flash player zero-day attacks in 2015. To achieve this goal, there were two problems need to be solved. The first problem is how to get effective samples in the wild. I need to find some sourcing channels can provide effective samples in the wild. And the second problem is how to identify zero-day exploit from these samples, because the number of these samples may be very large. You need a tool or need an automation process. So I will introduce some sample channels I use. The first sourcing channel is products feedback. There are a large number of SWF samples from products or engines detection feedback, and there are new feedback come every day. These samples are effective because they have been filtered by products or engines detection rules, so they are effective. The second sourcing channel is URL crawl. Usually, there are several exploits integrated in one URL. The server side decide to check which exploit depends on software versions installed in victim systems. For example, if user's Java version is low, the server side will check Java exploit, but not IE exploit or Flash exploit. So if you catch an old Java CVE or an old IE CVE detection URL, you can crawl the URL in an up-to-date system. It may trigger Flash zero-day exploit. So you can catch this kind of URL and crawl them. The third sourcing channel is VirusTotal Intelligence. There are many SWF samples can be downloaded from VirusTotal Intelligence using query statements. Results show that zero-day sample may be submitted to VirTotal before it was disclosed to public. Attackers may submit their zero-day POC to VirTotal to check the AV detection. The fourth sourcing channel is URL pattern. Export kit or campaign URLs may have some pattern. If you check one kind of export kit or campaign, you may find the pattern of the URLs. And so you can catch this kind of URL and with them to detect. I got many samples and URLs from about sourcing channels. So I need a tool to help me identify zero-day from these kind of samples. This tool must have a low false alert because the number is large. So if the false alert is high, this is difficult to identify. This tool must have log to record exploit event when detected, and it must have high performance. So I write a little tool to help me identify. I call it Advanced Flash Export Detector, AFED. AFED is an IE build tool written by C++. It hooks Flash OCX in IE process to detect. It also hooks IE standard events to get current URL name, and it can write detections and behaviors to log file. Using AFED, I can make a simple automation process. You just register AFED, and every time load a URL in IE, AFED will hook Flash OCX to detect. It will write detection and behaviors to log file. When you finish all URLs, you can pass the log file with your self-defined rules to output results. So how to implement AFED? We know that Adobe introduced vector object mitigation in July with the help of Google Project Zero. Before the vector object mitigation introduced, all Flash exploits use crafted vector object to exploit. This is because craft one vector object is very easy, and it can achieve arbitrary read and write using the crafted vector object. This is the typical exploit flow before mitigation. You can see that the first step is to allocate several vectors and then check the vulnerabilities to craft one vector object. And then you can find the crafted vector object. Use this object, you can read and write the process memory, and you can do anything you want. You can build RP and execute shellcode and payload. So based on this exploit flow, I can deduce this ideally detection flow. Ideally, after the vulnerability has been triggered, we can check the vector object. If there is a huge length vector object, we can see that it is an exploit and log it. So I need a chance or a checkpoint to check the vector length. So I hook GIT point of AVM2. We know that almost each S3 method will be GIT'd before it be called first time. So after I hook the GIT point, we have chance to check vector object length. So practically it is like this. Before each steps, it will hit the GIT hook function, and in this function, we can check vector object length. I hook the key function of GIT. This is the basic execute manager verify function. It can be found in the AVM Plus open source project on GitHub. In this function, we can get AS3 method name from the method info structure. And we can also get the emitted native code address. So how to check the vector object length? I hooked the vector creating. There is a template function named new vector in AVM Plus project, which creates kinds of vector objects, because there are 4 types vector objects in AVM2. So there are 4 instances in Flash binary. After hooked the vector creating, you can get the vector object address. So you can use this formula to get the vector length easily. So finally, the detection flow before mitigation is like this. In the vector allocated steps, I can save the vector object address. And in the GIT hook functions, I can use the saved vector objects to check the vector length. This is perfect before mitigation, but after mitigation introduced, things changed. Exploit can't use vector object to exploit. They use other objects. For example, the latest Flash 0-day in the wild is CVE 2015-7645. This exploit used byte array-based object. By overwriting byte array length, it can achieve arbitrary read and write. So I need to improve AFED a little. By check the GIT native code, I found that the GIT native code prologos are almost like this. So I can hook the first 9 bytes to record each AS3 method call. And I have mentioned that AFED can get AS3 method name and GIT native code address by hooking the verify GIT function. So I can trace the each AS3 method call. So I can print the trace to the log file like this. So I call this is the samples behaviors, because each function, each base object's function, we can record the behaviors. So I can add heuristic rules based on the behaviors. For example, if a exploit use byte array heap 3, AFED will print lots of core flash utils byte array to the log file, because this is the constructor. So when passing the log file, I can add a rule to detect the byte array heap 3. Other heuristic rules can be added by analysis from recent exploits or your experience. For example, recently exploits also use bitmap data heap 3, so you can add a rule to match core bitmap data constructor to detect. Okay, I have forgotten one thing. We need to hook the Flash OCX loading. It is like Windybox module load event. So I hooked the com function called get class object function in URL mount. In this function, I can use EasyQuery class ID to identify Flash OCX is being loaded or not. Okay, all things are be done. So we can use this improved FED to check if there is a zero-day exploit. Okay, this is my reference. Inside AVM from Haifei and the Google Project Zero blog about the mitigations. Okay, that's all. Thank you. Because this topic is hard to do demo, so there's no demo for this topic. But if there is any questions, I can answer. Okay.
As you pointed out, when you were visiting landing pages,
Okay.
there are cases where you might not even reach the flush.
Oh yes, yeah. You're right.
How does it affect your browser?
In the beginning, I craft the landing page because export kit or companion URLs use same kind Flash arguments, so I can craft the argument from before export, so this can reach to the export code. But
So you modify the page.
yeah, I craft HTML to load.
Yeah.
Yes.
But you have to know ahead.
Yeah. Because you need to choose. Yeah, choose one kind of export kit or one kind of companion, so you can know the style. Yeah. Yes. Any other question? Okay. Thank you.